So we had a full-out lesson on graphing sine, and that was our introduction to trig graphing. And today we're going to graph cosine functions, and the only difference, literally the only difference, is the shape. So cosine is going to differ from sine just in shape. Sine started at the origin. Well, cosine is going to start at the maximum. So it goes from maximum to the middle line, down to the minimum line, back to the middle line, and then back to the maximum. And then the curve is supposed to look like something like that. This is what it really looks like. A lot of kids call this the horseshoe shape. That's how they remember cosine. You just have to remember that cosine actually begins at the maximum line. It's based on its work with the unit circle, but again, our Algebra 2 course, we don't really touch on the unit circle until you get to trig. So look forward to that when you take your trig course. So domain, range are brought up in this lesson, but it's kind of confusing, isn't it? Let's talk about that for a moment. We haven't talked about domain yet. These arrows indicate that the cyclical pattern continues forever. So the domain for an unrestricted trig function like this, for a sine or cosine, is actually negative infinity to infinity. So that's why we have to tell you to graph one cycle or two cycles. The range, let's talk about that next. For this particular one, it goes from -1 to 1. But in general, the range goes from the minimum to the maximum, which that's exactly what range means, so that makes sense. The period for this particular cosine graph, if I say it starts here and then it ends here, this particular one has a period of 2 pi. And the amplitude is the power of the wave, so the distance from the middle line to the upper line, which looks like it's a 1. We're going to skip ahead to some graphing examples. Remember that formula about how to find the period for sine? Well, it's exactly the same for cosine. So the period is normally 2 pi, and then if the b value is something other than 1, you got to divide by b, because it's going to either shorten or lengthen the period. So first, without graphing, let's just identify a bunch of things. So we want to know the period. Then I want you to tell me the range. And then I want to know the amplitude. And actually, I'm going to answer these probably out of order, but that's okay. So the period is 2 pi divided by b. So there's a 1 right here. So 2 pi divided by 1 would be, hello, 2 pi. I'm going to answer the amplitude question next. The amplitude is the absolute value of this number, so the amplitude is 4. So that means we're going to go up 4 units and down 4 units. So that tells me the range goes from -4 to +4. All right, same stuff here. Period, range, and amplitude. Again, I'm going to answer them out of order because I'm kooky like that. All right, period is 2 pi divided by b. There's the b value. So 2 pi divided by 4, please do reduce that to 1/2 pi, or pi over 2. The amplitude is this guy, 2.5, which means our wave is going to go up 2.5 and down 2.5. So the range goes from, I'm just using blue, try again, starts at -2.5, goes all the way up to +2.5. Come on, pen. There we go. It's been a long night for this poor smartboard, apparently. It doesn't want to work. All right, it's one more. The period is, oh, be careful, this is one of those fraction ones. So it's really like cosine of 1/4 times theta. So the b value is actually 1/4. So 2 pi divided by 1/4 is, remember we can't divide by fractions, so we take this 1/4 and flip it to the 4 over 1. So the period is actually 8 pi. And then the range and the amplitude, well, let's talk about amplitude first. There is a number in front here, guys. They just don't write it. There's a 1 right there. So that means my graph goes to positive and -1. So the range stretches from -1 to +1. Range still has to be least to greatest, just like always with all of our functions. All right, let's start sketching some stuff. So the only difference from the last lesson is the shape. So just remember for cosine, the shape looks like a horseshoe. So it goes like this when we're plotting our quarter points. So we still start, oh man, that was ugly. Try again. I don't know if that's better. We're still going to start at what we're calling 0, but what do I mean by 0 is the vertical axis 0. So we're going to start at the top line, the maximum line at 0, and then plot our quarter points after that. And again, just like the last lesson, labels are key. So you're going to plot the shape. You know that there's 4 points here, 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 here. but you gotta label them. So the amplitude I see is 1.5, so I'm just going to arbitrarily draw in what I think are symmetrical lines, or not, but I'm going to label them. So this is 1.5 up, this is 0, and this is negative 1.5. Very important that you label. Then I'm going to graph the shape of one cosine cycle, which cosine starts, instead of at the origin down here, it's up here at the top, the maximum line. And then the next time, and you do want to space these equidistant from each other as best you can, especially if you're me, because it's not going to be good. Well, it's pretty good. And then these are really hard to draw, in my opinion. A lot of kids make them like V-shaped. You got to be careful. They're curvy. It's actually the same wave as a sine. It's just shifted over a little bit, so the starting point is different. All right, now for the labeling. We didn't talk about the period yet. The period is, remember, 2 pi divided by b. Well, if I look at my function, b is 2. So the period is 2 pi over 2, which is pi, and then I think it's crucial that you guys find the quarter points. So the quarter points is where you take the new period and you quarter them, cut them in 4. So the new period is pi, cut into quarters, this doesn't reduce, so this is what we're going to count by. So this is 0, check. This is 1 pi over 4, I'm going to have to label here. So this next point must be 2 pi over 4, we'll come back to that. And this must be 3 pi over 4. And then this last one here must be 4 pi over 4. We'll come back to that. Because after you've labeled them, go back and reduce anybody. So like this guy and this guy can reduce. 2 pi over 4 is pi over 2, because it's half. 4 pi over 4 is 1 pi. Now that's ugly. What some kids like to do is they do their work for their quarter points, like list them off to the side and reduce them off to the side of their paper, and then they go back and label them on the graph itself. Some kids I've seen label the graph first, like they mark their tick marks and then label it and then go back and draw the curve over it. I don't care. Just make sure it's labeled by the end of your problem. So 3 cosine theta. So the amplitude is 3. Sure, why not? So label your axes, your vertical axes. And then let's try that method where we label the axes before we draw. So I know, because I'm going to be graphing one cycle, that I need to, mark, after the 0, mark 4 points, the quarter points. So I'm going to be labeling 1, 2, 3, 4 things. Let's figure out what those 4 things are. So the one moment. Telemarketer. Alright, so the b value in the function, there's a 1 there, so that means the period is not going to change, right? The period is still going to be 2 pi. 2 pi divided by 1 is still 2 pi. Whoops. So these labels, these quarter points, I got to figure that out. So quarter points are when you take the period and divide by 4. So that would be 2 pi divided by 4. Please do reduce that though. That is a 1/2 pi. That's pi over 2. So we are going to be counting by 1 pi over 2. Here we go. This is 1 pi over 2. This is 2 pi over 2. This is 3 pi over 2. And this is 4 pi over 2. However, I want you to come back and reduce this. 2 pi over 2 is pi, and 4 pi over 2 is 2 pi. That was sneaky of me just to write over it. I should have erased it. If you were using pencil, that's what I want you to do. Go through and erase it. And P.S. You should be using pencil. Come on now. Alright, we're graphing cosine, so don't forget shape. Cosine starts at the top. So instead of at the origin, it's going to start up here. And then you just plot one quarter point after another, going in order. That was beautiful, Bruzo. You're welcome, kids. Alright. Cosine 4 pi. So this time the amplitude is just a good old 1. Which, whatever, I'm just going to label it. 0. And negative 1 down here. I kind of liked that, marking up the quarter points. So I know that's going to be 0, but we're going to have to label 1, 2, 3, 4. Alright, let's go figure out the period, because I think it's been changed. Okay, that was supposed to be 4. There we go. The period is 2 pi divided by b So when I go in my formula, that's b. So 2 pi divided by 4 is pi over 2. Oh, yuck. This is going to be fun. All right, here we go. Quarter points. You take the new period and you quarter it. So the new period is pi over 2, and we're supposed to divide that by a 4. Now think about how you work with fractions. Keep the pi over 2 as it is, and then instead of divide by 4, what if I wrote it as multiply by 1/4? That would work, right? So multiplying across here, you get pi over 8. Oh, that's going to be fun to count by. Here we go. I'm going to do this in green, and I'll write over in blue again. This is 1 pi over 8. This is 2 pi over 8. We'll come back to that. This is 3 pi over 8. And this is 4 pi over 8. We'll come back to that. Like right now. So 2 pi over 8, better known as 1/4 pi, which is pi over 4. 4 over 8 is half pi. So this is pi over 2. All right, that was the hard part in my opinion. Now let's just know the shape and let's graph. Cosine, don't forget, starts at the top. It's confusing when you're on a test and they interchange cosine and sine randomly on a worksheet or a test, and you got to remember which one you're graphing, and that's a very common mistake, is just kids graphing the wrong shape. It's not a huge mistake, but it is a concept, so you got to be careful. All right, let's see. Oh, there's one more. Why not? Let's do this one for fun. Period is going to be changed, and the amplitude changed. Ooh, and it's negative. All right, so the amplitude's 3. So I can label those. That doesn't change with the negative. But what does change is the shape. So because it's been reflected, the shape is going to start at the lower line, the minimum. And it's going to be upside down, to use a not so mathy term. It's been reflected. It's going to look like this. So I'm drawing myself a note because at the end of this problem, I'm going to forget the shape and then I'm going to screw it up. All right. The b value is, this is really like a 1/2 times theta, right? So the b value is a 1/2, which changes the period. Period is 2 pi divided by b. So 2 pi divided by half would be, flip that fraction, so 2 pi times 2 is 4 pi. Let's talk about the quarter points. Quarter points, take the new period and quarter it. All right, we are going to be counting by pies. I can do that. Let's label it. Starting at 0. 1, 2, 3, 4. And I'm like so excited that this was an easy one, right? 1 pi, 2 pi, 3 pi, 4 pi. I don't even have to reduce. I knew the period was supposed to be 4 pi. I'm feeling good. And then I'm going to mess it up because I'm going to graph it wrong. Because I know it's cosine, but don't forget it's been reflected. So instead of starting up here at the top, we're going to start down here. And then you just keep on going. I can almost guarantee that during class I'm going to mess that up. It's a near guarantee. Oh, that was ugly. All right. You know, it's a bruiser. You get what you get when you're graphing. All right, I think that was the end of the lesson. So we've graphed sine and cosine, really basic graphs. I want to talk to you about what happens when you vertically shift them. And then that's it for graphing for Algebra 2. We do have some applications and modeling coming up, but that is our official last lesson while we learn that one. So we are almost to the home stretch here, guys. Good luck.